Hi friends, welcome back. The next way to differentiate the signals is whether the signal is deterministic or random in nature. So what they mean? A deterministic signal is one which is exactly predictable. That means we can write a mathematical expression or the form of expression so that at any given time in future we can precisely tell what could be the value of that signal and all that. For example, we can say that x of t is sine of 2 pi t. So just substituting the value of t into the sine of 2 pi t, we know the value of it, and that will be the value of x at the time t. So we can exactly predict what could be the value of the signal at any given time. So if we have such a thing, then we can call it a deterministic signal. But usually that's a rare case. Mostly what we come across in our real-time life is what we call a random signal that cannot be precisely predicted. It can only be described statistically. So what does it mean? That we can't write an expression, a mathematical expression for a random signal. We can just tell how the signal could look like, or what could be the values of the signals, and what all the values of signals it can have, and what all number of times that value of signal can be repeated and all that. Some way statistically we can describe the signal, but we cannot predict exactly what could happen at any given time in future. So the useful descriptors for any random signal could be the mean of the signal variance, so how much the variability is there around the mean, and maybe correlation, autocorrelation, so how the signal itself is correlated with itself at different times and all that. So that way we can just use these types of descriptors to describe statistically any random signal. So random signals usually used to model noise, because noise is purely unpredictable. A signal, whatever we are talking about in our signals and systems, may be predictable because signals are one which we may be defining ourselves. But the noise which is present in the system, the noise which is present in the atmosphere, the noise which is present in our system around and all that is purely unpredictable. Therefore, the noise can be modeled as a random signals. So here the image clearly says the difference between what deterministic signal is and what random signal is. So you can see that deterministic signal has got some pattern, and now the same pattern can be just copied and pasted here, and that continues further. So we can just keep on pulling this copy paste, copy paste, copy paste, and at any given time we can exactly predict what could happen in future. So we know at this interval what has happened, but after this what could happen. If we think that the signal is going to exist forever, then the same thing continues, same pattern continues, and if that is the case, then we can just find a mathematical expression for this signal, like x of t, and then just substitute value of t, we can get a value of x at that time t. But looking on the other side, a random signal you don't find any pattern in this, and therefore representing this in any mathematical form is not possible. And unless until we put that in a mathematical form, we cannot say what could be the value of any given time t. So therefore it is not possible to predict the value of the signal at any given time. But yes, we can describe this statistically, how these are done. More details to come in the future videos. But as of now, signal can be a deterministic or can be a random. So deterministic signals are used in system testing, whereas random signals model the noise. So noise is the one which is generated externally from our signal generator, or from our other than signal generator and other than our system. So many other systems are there all around, and they will be generating some signals, and those signals are not in our control. Therefore we can't predict what comes at any given time. Therefore that whole thing will be a noise. But when we are trying to test any system, then we want to give a particular type of input only, so that we can check what comes out and then try to understand what the system is doing. So that is what we call, if you are trying to test the functionality of a system, then we should give some known input to that, and that known input must be deterministic. Only then the output can be correlated with the input, and then we can understand what exactly the system is doing. Okay, so to understand very specifically, just put them together side by side. So we have a comparison. So deterministic signals can be represented or described as a mathematical equations or lookup table, but random signals you cannot represent in mathematical equation or even can put as a lookup table. So deterministic signals are preferred because for analysis and processing of signals, we can use mathematical models of the signal. Yeah, when we are trying to use the signals for understanding some system, then definitely we would prefer the mathematical form of the signal instead of the signal itself. So if we can write the mathematical form of the signal, then we can do many mathematical operations on that mathematical form of the signal, and then understand what exactly is happening in our system, what exactly our system is producing as output and all that. So many things we can do once we come down from the signal to a mathematical expression. So random signals cannot be used for analyzing any system and all that, because we don't know what input is, because it's random one. So when the input itself is not known, what can we do with the output, and how can we compare input and output when input itself is unknown? Then there is no point in comparing input and output and trying to understand what the system is doing, looking at these two, and both happen to be totally random and can't make any sense. Therefore this analysis and processing is not preferred when the signal is random. So these random signals can be described with the help of their statistical properties only, but cannot be used for any other analytical purpose and all that. The value of the deterministic signal can be evaluated at any given time, maybe past, maybe present, or maybe future, because we know x of t is a mathematical form. We know that x of t is a function of time. So we put that as a mathematical expression where t is an independent variable and x of t is a dependent variable, and just substituting the value of t. The t may be positive, t may be 0, t may be negative. If t is negative, then we are talking about the past. If t is 0, we are talking of present. If t is positive, we may be talking about the future, or vice versa, whatever way you define it. But anyway, the value of t will decide whether we are looking into past or present or the future. Anything can be computed just by substituting the value of t into the mathematical expression. So that is easily possible, but that is never possible with any random signal. You can't talk of any predictions. You cannot evaluate anything at any given instant. Example for a deterministic may be a sinusoidal, maybe exponential waveforms and all that, but on the random side it may be a speech signal. So if you just record the voice amplitude of my speech, it just appears to be random, because the different instances, the different words are uttered for our uttering different words, different frequencies, different magnitudes of the sound wave is generated and all that. And if you just look at the waveform of the speech signal, it just appears to be totally random. But yes, there can be some other way out to understand how to differentiate between two speakers' voice. Yeah, there is some distinction. Yeah, that's what we do in the future videos when we are trying to understand the signal and try to understand the signal in the frequency domain. Yes, we do have many ways to understand that, but as of now we are trying to convince that there are two types of signals possible. One can be deterministic, for which you can write a mathematical expression, and if that signal passes through some non-deterministic signal, then for that deterministic system, if the say deterministic signal passes through any deterministic system, so we call the system deterministic because we can write a mathematical expression for that, which we call transfer function, which relates input to the output. And if we can write that, then we can compute the output using the transfer function given input. So input is known in the mathematical form, that is the signal. The system is known in the mathematical form. Then combining these two, we can get what could be the output and all that. So that is possible. So that is only possible when we are dealing with deterministic signals, we are dealing with deterministic system and all that. But all the time, everything cannot be deterministic. There will be noise in between, and we need to look carefully what to do with deterministic system, deterministic signal, and what to do when the system or signal are having some randomness. So that is what we need to look in future. What if we can comfortably put everything in mathematical form? So deterministic life is quite simple, but it is not so all the time. There will be randomness in signal as well as system. Then how to deal with that is one goal of this subject, signals and systems. So as of now, that's it. Thank you.